the second important point that I would again explain with ray optics. We had some 1 or 2 lectures ago 2 mirrors or 2 metallic planes that have been plumb parallel and allowed for propagation of a wave by multiple reflections in between that. So we had a ray that has been reflecting and traveling along that 2 mirror transmission line. Now, there was something which was a critical case, and that was the case of 2 mirrors that have been just 1/2 wavelength apart. This resulted in a wave that only bounced up and down and did not move along the transmission line. This situation would be called a critical frequency. For a given distance of those 2 mirrors, the frequency would decide whether the wavelength is bigger or smaller, and therefore at some frequency you would have just the half wavelength equivalent to the distance of those 2 mirrors. Under that, you can have a propagating wave. Over that, there is a wave that is propagating. That frequency, which just causes this to be 1/2 length, is the critical frequency of a mode, which we would now describe as, for example, TE1. Because there is 1/2 wave of a standing wave between those 2 mirrors. Of course, if we double that frequency, we would have another critical frequency of TE2. If I'll call this 1 and 2, we would know that FC2 is 2 FC1, because this should be a half wavelength in this case, and this should be 1 full wavelength in this case. So you have, for a given setup, for a given cross-section of a transmission line, one can get a set of frequencies that are called critical frequencies, and those frequencies form bounds for propagating a mode. Under that frequency, the mode cannot propagate. It could somehow exist damped inside as an evanescent wave, but it cannot propagate. Over that frequency, there is propagation. For each setup, we have 1 mode which is called dominant. And this is the mode that has the lowest critical frequency. So its propagation starts at the lowest frequency from all the modes. Now, to train a little bit what we have already learned, we already have been talking about a TEM guiding structure, which was being called a coaxial cable. So what is the critical frequency of the dominant mode of a coaxial cable? Who knows? Well, a hint, can a coaxial cable support DC? It can. You can use it for transmission of a DC current. Therefore, the dominant mode in a coaxial cable runs from DC, which is 0 frequency. So the critical frequency for the dominant mode of a coaxial cable is 0. Now, for other guiding structures with transversal electric or transversal magnetic waves, there is a non-zero critical frequency of the first mode, and this bounds the transmission. And as I promised you the equations for the next week, this is possibly all we can do today. So, first, let us switch back to organizational items. This week is the last teaching week within this term. Within this year, calendar year. We will have one more lecture in the first week of January, which comes on the 5th of January 2021. At that lecture, please have your Smith charts, at least one copy of a printed Smith chart. The PDF is in the file section of this Microsoft Teams group. And please have a pencil or a pen because you will need it to draw into that chart. We will, at the next lecture, use Smith chart to combine impedances like resistors, capacitor, and an inductance, for example. Then we will use it to describe at least one method of impedance matching, and then we will draw the equations for a waveguide. At the same time, I will prepare a video from the lab which will describe you and show you real waveguide components, so that you will not only see my pure sketches at the whiteboard, but you will be able to see real waveguides, and that hopefully will help you a little bit to understand the topic. Well, that's for the beginning. Second, we will have, for those who are in a hurry, an examination this Friday, as far as I remember, at 10 o'clock. So once I will see those who will be subscribed in COS, I will make a special group. It will not run in this group, this is a lecture group, a special group in Microsoft Teams, and invite you, those undergoing the exam, to that group. Now, to be on the safe side, if there is still a problem on Thursday and your Zapochat assessment from Professor Machacz is not in the course, please contact me on Thursday, and we will have to sort it out. Just in case, because COS is a computer system and each program contains at least one mistake, and as you know, by correcting that mistake, you create at least one more mistakes. Then, we will have the examination on Friday, and after that there will be holidays, winter holidays. We will not run regular consulting, although I will be in Prague like more or less everybody in this country. We do not have much traveling this winter. So I may be available for consulting, just you have to send me your request well ahead. So that's the second point. The third point, if I may, I would like to wish you nice winter holidays, or Christmas or New Year, as you are used. It depends on your culture. But anyway, I am looking forward to meet you on the 5th of January. And at that time, we will also make some agreements on consulting during examination period. As a preliminary start for your thoughts, our examinations are scheduled on Fridays, and in that case I suggest that I will prepare regular consultations around Wednesday middays, just before the examination. That's 2 days before the examination. That's a time at which you already know something about the subject, so that you know which questions do you want to ask, and still you have some time to absorb the results and to learn that. So that consultations would be scheduled for Wednesdays. We will skip our Monday consultations during examination period, and I will schedule consultations for Wednesdays. And not each Wednesdays, but Wednesdays that are 2 days before a Friday examination. Is that is a starting point, and we can make also other arrangements. And of course, I'm going to do as much as I can for other consultations if you ask me some time ahead. So that's my point. Now, are there any questions to what a dominant mode is? If not, then we should possibly wait for the video I will prepare for you from the lab. And hopefully, one day the coronavirus would end, and if shall you wish then to see those things in real and to carry it in your hands, to touch it, let me know and we will arrange somehow, because I understand that it's impossible now to visit a lab during a lecture. On the other hand, it's helpful for understanding, and I feel I owe you that unintentionally, but if you want to get that, let me know later in some better times. Anyway, I wish you good health to you and your families, and I'm looking to meet you again on the 5th of January in the year 2021. And some of you possibly this Friday at an examination. See you and good luck.
Thank you, sir. Bye.
Thank you. Bye.
Thank you. Bye.
Oof.